So since you can see that there is a italic font on the title, you'll know that this is a hot take. So I'm gonna say something that is different than what people are claiming what ZKML is for, at least for now, and I will explain why that is. Uh, uh, but before I start, actually, I really appreciate David giving the Sudoku example because I actually started writing some of my circuit using Sudoku as a first try as well. And at that time, because of all these like arithmetic circuit, and also most of the time these circuits are not Turing complete, it's actually better to not write it the way you would write it normally, right? Which is just checking whether 1 to 9 all exists. So I think I got attracted into ZK because of that. Like there's something that like intuitively using a Turing complete language is very intuitive and very natural. But then when you want to get it into ZK, if you want it to run sufficiently fast, there are some tricks that you have to do, and especially with machine learning. So that's kind of well, just a forward to what I'm going to say. So ZKML 101, this is pretty much like the slide that I attach in the beginning of each of my talk right now. And so this is when we talk about ZKML, this is usually what we are referring to, which is you have some ZKP circuit. It could also be a VM, right? A ZKVM, but basically you are able to run machine learning models on in ZK. Usually when we talk about that, we mean something like a neural network. Okay, so neural network is the fanciest models you can get nowadays. So this is the ultimate goal. But in general, more generally, machine learning models. And then we have input data, and model weights that goes into the circuit. And it will give some prediction, which is the output. Right. And then from here, we can talk about different use case. So let's say here, um, well, in David's slides, there were public inputs and private inputs. Right? So we can define these two inputs to be public or private. Usually when people talk about privacy, they are referring to the input data being private input and the model weights being public input. Or vice versa, when people are talking about, hiding the model, right? Some proprietary model. The model weights might be private, whereas the input data may be public. Doesn't make sense for everything to be private, otherwise we're not really proving anything. Lately, another class, which is really inspired by rollup or succinctness, is for both of these to be public. Right? So we don't really care about any privacy related applications. We want a proof of computation or proof of storage. Right. So that's pretty much all the technicality we'll get today. We're going to talk about use cases from here. This is related to the different use cases that I mentioned just now, which most of the time when people are talking about what's ZKML for, almost instantly the first thing you'll hear is privacy, right? And privacy, and then the natural use case after they say the word privacy is biometric authentication, right? And that includes scanning your fingerprints, scanning your face, scanning your iris. Yeah, no, I keep wanting to say retina every single time, and I have to correct myself and say iris, right? Iris, fingerprints, and face. Well, there is a problem with this class of use case that we're referring to, which is the problem that we cannot do it client side. So far, at least for I think even for a fingerprint model, so not even to mention facial recognition, for fingerprint, we can't do it client side, like, or it will take forever um, with the memory and time trade off that David mentioned. So then maybe it's not really for privacy, or if we think about it as privacy, it's very difficult to achieve for now. So privacy is out of the window for now. Well, then what else is ZKML for? Then people would be like, it's for transparency. Okay, transparency of what? Transparency of model. Okay, so this is an ERC that I wrote. Basically, is saying that we can have transparency of machine learning models if we encode it in ZK, right? And we just submit the proof or the trace to the blockchain. So when we talk about transparency, it's pretty much like we're expanding or extending the capability of the blockchain. Right? For example, on Ethereum, the contract size is 24 kilobytes, and the block size is also limited. You can't really have big models running out there. So what if we run it off chain and use this as sort of a machine learning rollup? Right. So that is also true, except maybe perhaps not a lot of people care about this. Right. So why do I need a model? Like, why do I need to run a model on blockchain? Right. So you need to give a reason, and transparency itself is not a reason. We first need a reason to run the model itself on blockchain. Right. So that's also out of the window. And the next thing is, okay, what is ZKML for? For gaming. That's also another use case where people talk about. And the biggest example when we talk about ZKML in gaming is this thing. So it's by my friends from Modulus Labs. It's called Leela versus the World, where they basically train an AI agent to be able to play chess against everyone in the world. Okay, so the funny thing is, this particular game is not really about how good or how bad Leela is. It actually plays on personal like greed. So instead of like everyone just playing against Leela, you can also buy whether human moves will win or Leela will win. Okay, so that's the actual gaming part if you think about it. Not the AI, not playing against the AI itself. So this is a fun game, and of course we can do a lot of play on that. But then again, it's not really particularly. There's not a particular reason why it has to be on chain to begin with. It doesn't really use this kind of anything that's related to the blockchain. And so that's also the other another kind of use case. So now it's kind of the hot take. I'm not saying that the use case just now are invalid. I'm saying that there's a Frankenstein term that can cover all these use cases. And that's fairness. Okay. And I'll explain in a bit why I'll introduce this. I'm not saying that this is the only use case for ZKML. I'm saying that, like, if we think about this in this way, it can actually break up a lot of the limitations that we have set for ourselves with privacy or with transparency, and also kind of like just a new perspective of how we think about the different use case. So fairness. Why fairness? So it begins with this is the example that I always give. So back in I think April, Twitter open sourced its algorithm, right? Its recommendation algorithm, and so everyone are able to go onto GitHub and just look at it, right? So that's a tweet from Elon Musk, and then this is a tweet that I found the other day from doesn't matter who that is, but recently I saw some people talking about friend tech. Okay, I'm not a big fan of friend tech, but I know a lot of people are using it, and they are rewarding people by how much they use it, right? And pretty much there's this guy who was like, okay, I got this many points. And then this other guy is like, how do they even measure being active? Right? You don't really, it's the same thing with airdrop or anything that you do. How do you even know how to calculate it? You don't really know until you get the airdrop itself, and then they're like, hey, this is how much you get. So how do we actually attempt to solve this problem? And even if you open source the algorithm, the problem is we don't know whether Twitter is actually using that algorithm. Right? So it doesn't matter. Like even if I'm a programmer and I understand the algorithm fully, doesn't matter. I don't know what is my data, first of all, right? And I don't know whether it's applied on me. So what does it mean to have fairness in ZKML or use ZK for fairness? So first of all is we'll be able to ensure that the algorithm or model is applied on anyone, or sorry, everyone actually should be everyone. For some use cases or application, it might not matter as much. For airdrop, maybe people will care about fairness. the other thing is also to ensure a model upgrade is publicly known. And this is particularly like relevant with nowadays. I don't know how many of you use ChatGPT on a daily basis, or even more commonly use voice recognition on your phone, voice input, right? Voice to text input. If you realize, at least for me, the Cantonese model has gotten worse and worse every day. And not just that it's getting worse, it's given me more choices. Like it's being more and more uncertain, and it gives like 1,000 of choices when it hears what I say. So actually, what if I don't want a model upgrade, right? What if I buy a service and I actually just want to use that model, right? How do I know at least when the service provider upgrades something? So that could be kind of one use case, right? And so the use cases in this case will be like social media or even recommendation system. So currently we don't have any like CRM or marketing in Web3. Most of the time it's either, for example, for a lot of the Web3 social media, it's just people you follow or second layer connections, right? So there's no algorithm because there's no trustable algorithmic way of saying that, hey, this is what we're showing you. Instead of, to show that it's not sponsored or tempered. Right? So if we are able to have some kind of algorithm being applied on your data and that's being transparent, that could help with this fairness problem. So now we can go back to all of this, our use case, and try to think about it from another perspective, right? So a lot of people are thinking that since we cannot do client-side, since we cannot do client-side proving as much, at least not for big models yet, they often think that biometric authentication is out of the window. We cannot do it. But the truth is, even nowadays, we are sending our data to servers, right? So what's the difference that Web3 could make without saying we have to go all the way to client-side proving? Well, one intermediate thing could be, well, we still do server-side proving, right? We still send our data encryptedly onto a server, but the server aren't able to censor us, right? So it's not a hidden model, right? Let's say if there's a service that offer biometric authentication as a service, they cannot censor us by saying that our data is incorrect. They have to show a proof that it's incorrect. Right? So that means that there's an unbiased service of biometric authentication that even the service provider themselves cannot like tamper with themselves. So that's one way, even without client-side proving, that this could be useful. Right, so it could ensure that the same algorithm is always used to access your credentials, right? So your username or your particular user ID is not being treated differently, and there's no censorship. So that's a possible kind of way to think about authentication problems. Right. Model transparency. We can also think about it as a use case or from a fairness perspective. Right? So you can think of it as we can ensure the service that we purchase or subscribe hasn't changed. And most importantly, we will also be able to decentralize the proving process. Right? So instead of saying that something has to be transparent, it's more about like, let's say if we want to decentralize the proving process, say in a CK Oracle, you can make sure that they're using the same model to process your input. Right. And as for gaming, actually, we can also think of it as a fairness where you can pretty much like if you have an AI agent, you are ensuring that everyone is playing against the same game, which is often not the case for some of these Web2 games, right? Whereas it's very hidden, you don't know exactly what's happening. And also, you can ensure that changes in game mechanisms are visible, right? So the game mechanism itself can be hidden, can be private, but at least if there's any change into the commitment, you'll be able to know. So again, from a fairness perspective, this could be, and this is not necessarily machine learning. It could also, again, be like a signature or a commitment in this case. Right, so that's kind of all I have for the ZKML part. I do have a little bit more slides later, But as kind of like just a TLDR of what I just said, pretty much that I guess the hot tip today is that every single case of ZKML that we have thought about right now boils down to kind of fairness, being like the same model applied to everyone or every user or every address, or so what like if it's the same use cases that I'm mentioning, then why is it important? I think one thing that is important is that now we could start thinking about server-side proving, and it's not being as much as a taboo compared to when we talk about like privacy and stuff. So hopefully then there are some more like new ideas or directions that can spawn from like thinking about the use cases in this way. Right. So that's the part I have on the topic. I also brought some alphas here today. Since I know that there's a lot of PSE members and also a lot of our summer contribution program members here. And I really, so one of my jobs, the reason why I fly here for this particular meetup is to recruit. And so really the alpha is what are we building at PSE in ZKML. And the truth is we are really trying to push these initiatives. So we are trying to get people who will adopt the app or the idea itself. So one of the things that we're trying to do is to actually make the 707, the ERC, into an actual app. So right now it's still an interface, it's just an ERC. So we really want to make it an actual app where people can play around with it. There has been a kind of small scale app that was submitted, I believe, in, I want to say ECC, called like Synthetic NFT, but they're not exactly using a machine learning model. They're using more of like an abstract art, like, yeah, it's just like a bunch of color mixed together, like a genetic algorithm kind of thing. So we want to actually have a Gen AI model, even if it's a small scale one, a small resolution one. We want to at least show exactly how the whole process will work, right? So how does the proposer of the prompts interact with the server, and how does the server actually like how does the server actually interact with the prompt proposer and interact with the contract? So when you actually like on the surface, the ERC seems simple, the implementation process seems simple, but quickly you will run into a lot of design problems, which is like, for example, how to prevent front running, right? If a person knows that your prompt is being sent to the prover, will they be able to front run it? Or even what if the prover thinks that your prompt is a good prompt and they steal it? Right. So there's a lot of kind of like these things where it also interacts with the smart contract. So if you're Solidity engineers, I think that's what that. And also with some machine learning background, this could be a fun project. Yeah, I just kind of screenshotted it here. So if it's too much information, just read this. That's pretty much the main point. Yeah, so here the MVP is this. The second one is I'm actually looking for someone to do it with me. So that would means that someone who is fluent in circuit writing. We haven't picked a language yet, but most likely Circum because we're using folding scheme and Innova in this case. So pretty much our MVP is trying to prove a state-of-the-art LLM in a reasonable time frame. Okay, so why is it in quotation mark and why did I say state-of-the-art? So right now we do have GPTs in Halo 2 that has been run by I think Daniel Kang's group. They have gotten GPT-2 and I think also GPT-3. I'm not sure. But the thing is, it's not something that you can even run with consumer grade cloud servers, right? We're talking about terabytes of RAM. So one thing to get a state-of-the-art LLM in a reasonable time frame is actually through this kind of interesting class of model, machine learning models called RWKV. I have no idea what the actual full name is. Yeah, no, this is the name of the model. The R I believe stands for recurve. Okay, so basically this group of people, not for ZK, but somehow they did the same optimizations that happen to be relevant to ZK, which is they want something that are able to run with a small amount of VRAM, virtual RAM, and also parallelize it. So this is the automation optimization that they did, and they were able to get pretty much an LLM into a recurrent neural networks style with no attention needed, if you know what that means. If you don't know what that means, this project might not be for you because there's an intensive kind of like large language model, transformer sort of background knowledge. But yeah, so happens that these group of people, they did a model architecture that could be perfect for voting. The idea is if we are able to also parallelize the proving process of, well, sorry, not the proving, the IVC process of Nova, then we are able to speed up this essentially, right? So maybe what we could do is instead of running it on the server, at least maybe we can run it with 100 laptops or something like that. So that is kind of like what we're trying to build in the next few months or so. Cool. So if you're interested and if you think you have the expertise, feel free to find me after to talk. Yeah, we also have some bounty styles projects coming up, and that will be releasing soon. And that will be like smaller scale projects compared to the two that I just showed you. So it would be something like, study this, move this model into ZK and have some like write a research report or something like that. So that would be like more of the bounty style code.
Where they can find the information.
PSD? When are we really releasing it?
There's a GitHub repo on that.
It's private.
I think we're gonna have an announcement. Follow the Twitter.
Follow PSD, Twitter.
Yeah. So right now, we're still writing up the bounties. So when they are released, it will be on our Twitter. We'll announce it on Twitter. Yeah. Cool. Yeah. So that's all I have. I don't. There's not much technicality in the slides today, so I don't think you really need them. But in case you want them, it's there. Yeah.
Great. Any question though? Okay, hold on.
So my question is about kind of go back to privacy. So will combining FHE and ZK will be an interesting idea to kind of enhance the privacy.
It's kind of interesting because I'm getting this questions the third time this week. And I'm wondering, is this what everyone is talking about or thinking of? Okay, at least to my personal understanding, we do have some kind of zero knowledge FHE program that's running or researcher that's running in our team right now. But at least on the AI side, like I know there are companies like Sama that is doing fully homomorphic encryption on AI. And to be honest though, I think FHE alone might be enough in the privacy use case. Okay. I think as long as, well, you might still think of it as some kind of proof of knowledge. Right, sorry. I don't think it's useful. But anyway, so you can still think of it as some kind of proof of knowledge, whereas the model provider, like the prover or the model provider running the model in this case, they might still need to commit the model in some way for it to be useful. But again, committing the model could be something that you eventually hash it during the process. So it's not so much as ZKML where I don't think the CK much is really needed if you already have FHE. But then again, FHE is a little bit, I think CK in this stage is a little bit more mature than FHE right now and in practical use. So, but yeah, that's kind of thoughts.
You want to ask a question?
So we've seen like lots of these really cool things, like you can put all these neural networks and stuff in these CK circuits, was something that I think we didn't think was possible like a few years ago. So I'm curious, what are your thoughts or intuition on like asymptotically, how far will we get? So let's say GPT-4, GPT-5, like is it 100x? Like what big will the difference be between the native thing and the CK thing? Assuming that we can realize all this folding stuff and distributed provers and stuff, do you have some intuition around what that would look like?
Recently there was a article by Daniel Kang's group, which is called TensorFlow. So they did a specific optimization of matrix operations when CQ was to get the time of your name matrix computation, which is the majority of machine learning operations. And they were able to get it down by, say, they claim to be 1,000 times. It's not open source yet, so I cannot verify that. But if that is true, then that means that we are pretty much just normal equivalent ZKML and ML operations. That's pretty much where we will get. Right? Like it's impossible for ZKML to get even cheaper than ML. That would be very weird. So yeah, but if that paper is true, then we are kind of already at where we are. That's only for time. Right? I'm not actually mentioning anything about memory consumption. It seems like for now, even with all the other schemes and even outside of CKM, I think memory is still the biggest issue. So yeah, I don't think it's. I think it's a more of a general improvement rather than an specific improvement.
Anyone else?
Hey, hi, Cathie. I just have a question regarding to because I just want one question regarding to ZKML application. So let's say I roughly know that there are two scenarios for ZKML to use. One is like public model, private data, and another is private model, public data. But I'm just wondering, is there a scenario like private data and private model?
Private data and fresh model. I think it's usually the third use case that we talk about where yeah, so it's about commitment, right? It's about showing that it's the model. Like this is the model that we're using. But yeah, but I think for the fully private use case, at least I couldn't really think of one. There is a use case though. However, let's say you start from a public model, node model, where you did some fine tuning, and there's actually some simples are doing this. And so you went from a publicly known model with some node fine tuning steps to some private weights. Yeah. But regardless, though, however, you still have to commit the weights to some kind of hash, so that so that you're proving you're showing that you're proving that particular model.
Okay. Anyone else? Sure.
Now, since we're on this page of biometric authentication, do you have any thoughts on WorldCoin and where that might, where that might lead in the future?
Gosh, this you really want to make me say it in public, huh? I think I've yet to say anything about it in public. My take is usually I think technology is the means to a solution, like to solve a problem, and but then there are a lot more other problems that are social, and I think so far like as yeah, so I think a lot of problems is social, and the technology itself might not be like the full solution to solve it. And just as a side note, WorldCoin is doing ZKML research, but their not retina, I keep saying retina, their iris scanning is not CK yet. So the CK part of them is actually the commitment onto the chain where you create a commitment, identity commitment in a Merkle tree. So that part is CK, but the machine learning part is not CK yet. But yeah, but I mean, even when we have that, I think there is still a lot of societal problems, like and social engineering problems that we have to solve. So the technology is just like part of the solutions to the whole problem.
Maybe one more question. Anyone? Cool. Maybe do you want to say something before we end this? You'll be fine.
Not really, but yeah, you have machine.
Please, yeah, please.
I'm desperate in need of someone to help me work on.
Desperate. Yeah, we need talent. So thank you everyone for joining us today. And